to you how we are supposed to solve differential equation. We will be taking few questions from previous year question paper and we'll be solving over here. So let's take few questions. Just a moment. So the question, one of the question is like this. Let f be a non-negative function lying in this interval if integration of 0 to x 1 minus f dash t, that's a square. This is f dash t, okay, that's a square. Dt is equals to 0 to x f of t dt, where x lies between 0 to 1, and f of 0 is equals to 0. Then limit x tends to 0, 0 to x f of t dt is equals to option A 0, option B 1, C doesn't exist, limit doesn't exist, and option D is 1 by 2. Okay, this is the question we are having. Let f be a non-negative function which is lying in between 0 to 1. If this is the integration is given over here, then we have to find the limit x tends to 0 f t dt. Okay, let's see how can we do this. So let me write the question over here. This part, this integration is given over here, that is 0 to x under root 1 minus f dash t, that's a square, dt is equals to 0 to x ft dt. Here we have to find limit x tends to 0 ft, this 0 to x ft dt. Okay, so at first we will focus on finding f of t, okay, or maybe f of x. So here if we are having this condition given in the question, we need to differentiate both sides so that we will get rid of this integration sign. Once we will differentiate, that means antiderivative we will do. Here we are having antiderivative, derivative we will do, and we will just get rid of this integration sign. So to get rid of integration sign, we have to differentiate both sides. Okay, when we are having this condition and when we are going to differentiate it, there is a rule. Let me write the rule. We will be following that rule only. So the rule is given by Leibniz, and the rule says if we are having f of x is equals to u to v ft dt, then f dash x derivative will be, derivative of such integration will be f of u, it is f of v times v dash minus f of u times u dash. Okay, this formula given by Leibniz we will be applying over here on both sides, okay, separately. So we have to do the derivative on both sides. So the formula says if we are having this type of derivative, at first we will be putting the upper limit in the given function. Okay, at first we are going to put the upper limit in the given function. So the given function will become 1 minus f dash, it is t, and upper limit is x. So it will become f dash x. That's square. Okay, and after that times v dash is there. Okay, that means d dx of x we have to do here. Again minus sign. Then what we have to do, we in the same function, in the same integrand, we will be putting the lower limit. Lower limit is 0, so it will become 1 minus f dash 0. So it will become under root 1 minus f dash 0, that's whole square, times d of d dx of 0, okay, is equals to the same thing we will be repeating over there. So it will become f dash x, sorry, only f of x, because we just need to put the upper limit in the function, in the given integrand. So it will be f of x times derivative of the upper limit. Okay, so times 1 directly I am writing here, minus f of 0, and again derivative of this 0, which is 0 only. Okay, so here you can see that we are getting on the left hand side, we are getting under root 1 minus f dash x, that's a square. Derivative of x is 1, and this derivative of 0 is 0, which is making the other part completely 0. Okay, so on the left hand side we are having only this one, and on the right hand side we will be having f of x only. Is that clear so far? Is it clear?
Yes, ma'am.
Let's move ahead. Now we will be doing squaring both sides to just get rid of this square root sign, or we will think about how we can proceed so that we will get f of x. Squaring both sides will give 1 minus f dash x, that's square, is equals to f of x, that's square. Okay, now if we will write f dash x, I am just keeping on one side separately, square is equals to 1 minus f of x, that's a square. Okay, now this is square root is transferring into other side, it will make a square root. So we will be having 1 minus f of x, that's a square, is equals to f dash x. Why we have done like this? Now only I am going to show you. Okay, if you are thinking that once we will transfer this square, once we will just put the square root sign, there will be plus minus sign. Yes, there will be plus minus sign, but since here in the question it is written that f is a non-negative function, I am keeping only plus sign over here. Okay, now it will become f dash x over 1 minus fx, that's a square, and here only 1. Can you see we can do the integration on both sides? And yes, it is possible to do the integration of this function. We will be taking the denominator as a substitution and we'll be getting the numerator only. Okay, so let's do the integration on both sides, integrating both sides. So we will be having here dx, here we'll be having f dash x dx under root 1 minus f of x square. If we will be taking f of x as a, let's say u, so f dash x dx is equals to du. Can you see we are easily getting the numerator? For that only we have done this here and there, first doing squaring and then just transferring this square root sign for this integration, so that we will be able to do the integration when we'll go ahead. For that only we have done all this arrangement over here. Okay, now here we will be having only x plus c, here we will be having, here it became du over here, and under root 1 minus u square. This is the formula for, can you see? this integration will give? Who will tell? Anyone?
Sine over x by a.
Yeah, what? A square minus 1 minus u square under root. Is it cos
Sine
or
inverse.
you said something, but sorry, I'm unable to, the voice is not that clear. Can you please repeat? Is it sine inverse? Yes or no?
Yes, ma'am.
So sine inverse u, here we'll be having x plus c, u means what? F of x. So we are having sine inverse f of x over here. And here we are having x plus c, constant of integration. Still we have to find so that we can go ahead and find this limit. So it is given that f of 0 is equals to 0. Okay. It is given that f of 0 is equals to 0. That means when x is 0, then y is 0. F of 0 is 0. So here sine inverse f of 0 we will substitute, which is 0 eventually. This is x is 0, c is equals to sine inverse 0. Sine inverse 0 is what? 0 only, right? Right? Is it 0? Yes or no?
Yes.
So what are we getting? This step. This one we are getting where c is 0. So we are getting x equals to sine inverse f of x. Okay, this sine inverse we can just transfer to that side. So that side it is sine x is equals to f of x. Okay, f of x we got as a sine x. We have to find the limit, the given limit. What is the limit? The limit is limit x tends to 0, 0 to x ft dt. Okay, limit x tends to 0, 0 to x ft dt. Okay, here we got f of x is sine x, so f of t will be sine t, right? So here we will be substituting that. Okay, we know that f of x is sine x, so f of t will be sine t. So here we can write limit x tends to 0, 0 to x sine t dt. Just a second. Now, one part I have missed here, it is also written that 1 by x square outside. Okay, this limit we have to find over here. Here 1 by x square outside, here 1 by x square is there. Okay, so we can write it as limit x tends to 0. This integration over x square. When we will substitute in the numerator, when we will find the given limit, what are we going to get? In the denominator, we are getting 0. In the numerator, if we will do, we will be getting, just a moment, let me check. Here we can apply L'Hopital rules. Okay, where here we can apply L'Hopital rule, which says that whenever we are having such a limit where the denominator is 0, and I believe the numerator will also come out as a 0, 0 by 0 will be having. So we need to apply L'Hopital, which says that for doing such limit, we have to do the derivative of the numerator and derivative of the denominator. For derivative of the numerator, again we will be using the same formula, the formula which I have written over here, this formula given by Leibniz. Okay, whenever this type of integration we are having and then we are going to do the derivative, we will be using this formula, that is f of v, v dash, f of u, u dash. So eventually here also we will be getting sin x, and here we will be having just x square derivative will be 2x. Yeah, still limit x tends to 0 is there. Now we know this 1 by 2, let's keep it aside. Limit x tends to 0, sin x by x is equals to 1. So are we having 1 by 2 as any of the option? Yeah, option D is the correct option. Can you see this is 1? Do you know this is 1? So 1 by 2 is the answer. Are you getting it? Yes or no?
Yes.
So 1 by 2 is the correct option. You just need everything we have done, the way we solve the differential equation. Only this formula, if it is not known to you, please write it. Note it down. Now the next question is, suppose we are having, if y is equals to y dy dx is equals to x y square by x square plus phi of y square by x square over phi dash y square over x square, x greater than 0, phi greater than 0, and y1 is equals to -1, then phi of y square by 4 we have to find. The options are option A 4 phi 2, option B 4 phi 1, option C 2 phi of 1. Okay, this one is the question. We have to solve this differential equation. We need to use the given condition, and then we from there we have to find phi of y square by 4. Let's see what can be done over here. So we are having y dy dx is equals to x y square by x square plus phi of y square by x square, phi dash phi of y square by x square over phi dash y square by x square. Yeah. So here we are having phi of y square x square, phi dash y square by x square. Here also y square x square. And if this x, we will just shift it on the other side. Here also we'll be having y by x. So y by x, everywhere we are having. Let's assume this y by x as a t. Okay. So if we will be having x square over phi dash y square by x square. Let's substitute. Let's take y by x is equals to t. Okay. So we can say y is equals to xt, and if we will do derivative with respect to x on both sides, it will become dy over dx is equals to first function derivative of second plus second function derivative of first. With respect to x we are doing, so only t will be there. So we are getting dy by dx is equals to x dt by dx plus t. Okay. So this became t. This became t. dy by dx is x dt over dx plus t is equals to y square by x square became t square plus phi of y square x square, it became t square over phi dash t square. This is what we are having after substitution. Let's see what can be done after that. This t, if we will send it to other side, so we will be having x dt dx plus t is equals to t square by t. Okay, this t will go over here and will be in division with the first term with the second term. So t square by t will be only t. Here we will be having 1 by t. 1 by t phi of t square over phi dash t square. This is what we are having in hand for now. Okay, now can you see these two are exactly same term, so we can cancel it out, this one and this one. Here also we are having t, here also we are having t, so it will just cancel out. Now we will just, here we are having dt, here terms related to t, here we are having x dx, so we will separate. Okay, variable separable, so we will separate it. Here we will be having dt, okay, dx by x I am going to transfer to other side, and on the other side this 1 by t, this one I am going to write over here by phi of t square over t into y dash t square. Are you getting it? Are you getting it? I have taken everything from here. Nothing is there. Okay, forget about this plus sign and t. Let me wipe it if it is creating confusion. We are just having this. Okay, just this we are having. So obviously we can separate it. Dx by x we can write on one side, and on the other side we can transfer everything like this. Okay, whatever is there, the circle part I have just taken and written in the denominator. If this is not making sense to you, then write it in the numerator and denominator the way it will be. So we can also write it as t phi dash t square dt over phi of t square. Are you getting it? Is equals to sign is there in between. Is it clear so far?
Yes.
Yes.
Let's move ahead. Now we will be doing integrating both sides, because you know you have seen the same case in the previous question and it is integrable. So we will be doing integration on both sides. This side and this side we will be doing integration. What we will be getting? So the left hand side, if we will substitute the denominator, are we going to get the numerator? Let's see. So phi t square, if we will take this one as a u, so we will be having phi dash t square times this t square is 2t. Chain rule we are applying over here. That dt is equals to du. Okay, so the numerator exactly we have got, this 2 is extra. Okay, so this 2 we will be shifting to other side. We will be having phi dash t square times t dt is equals to du by 2. I am going to substitute it over here. So we will be having du. Here we will be having 1 by 2. Here we will be having only u is just ln x plus c, constant of integration. Is it clear so far? Okay, both sides we are getting log log. Here also let me take logarithm only. Plus ln c. Okay, so what we will be having over here, we'll be having here also logarithm, here also logarithm. Here we'll be having 1 by 2 ln u is equals to ln x plus ln c. Okay, this is what we are having. This 1 by 2 we can send to other side. So we will be having, instead of only 1 by 2 ln c, let me check whether it will work or not. What we have to find here, we have to find phi of y square by 4. Okay, if we will be taking here also 1 by 2 as a constant we can pick anything, right? So if we'll be picking it like this, we will be having ln u is equals to 2 ln x plus ln c. 1 by 2 we have just cancelled out. So if we can have here logarithm of x square over here, log ln c over here, u over here. So u is equals to x square into c we are having. Can you see?
Yes,
Okay. This u is phi of t square. Okay. Phi of t square we are having x square into c. If we will substitute the given condition, that is y of 1 is equals to minus 1. Anything else given over here as a condition? No. So it is given as y of 1 is equals to minus 1. That means when x is 1, then y is negative 1. Okay. So constant, how we will get over here? When x is 1, then t. What we have assumed as a t? Y by x. Just a moment, no? T is equals to y by x. And u is equals to t square, phi of t square. Just a second, let me check how we will be using the given condition. Here, before using the condition, if we will write it as, let's say phi of t means y by x we have assumed, so y square by x square is equals to x square into c. If x is 1, y is negative 1. So c we are getting here, x1 we are substituting, so only c will be here, and here y square by x square is there, so phi of y square by x square, that means phi of 1. This is what we are getting in the option. Yeah, phi 1 is there. Okay, let's proceed from here. T square we were having, we have taken 1 over here. Okay, t we initially only t we have taken as a y by x. So here we are just substituting it back. Okay, back substitution we are doing, and we are writing the t. After that, we can use this given condition. When x is 1, then y is negative 1. Y negative 1 square is there. It is becoming positive 1. So we are getting c is equals to phi of 1. Okay, let's keep it in hand. And if we will be using this equation again, so phi of t square is equals to x square into c. C means phi of 1. Okay, t square means phi of y square by x square is equals to x square into phi of 1. This is what we are having in hand for now. What we have to find here, if you will look at the question, we have to find then y square by 4. On the left hand side, if you will see, our expression is phi of y square by x square, and here we have to find y square by 4. Okay, that means we have to take x as a 2. Are you getting it? Y square by 4 we have to find, and in our equation y square by x square is there. How to make it 4? If we will take x as a 2, then only this denominator will be 4. Okay, so we are taking when x equals to 2, therefore we will be having phi of y square by 4 is equals to, here we will substitute 2, so it will be 2 square, here we'll be having phi of 1, that means 4 phi of 1. What is the value of phi of y square by 4? It is 4 times phi of 1. Is there any option like that? 4 times phi of 1? Option B. Can you see? Can you see option B is the correct option? Let's see from the very beginning what we have done. This was the differential equation we were having. Okay, whenever we are having differential equation, what we do the integration, we use the condition, we find the constant of integration, we again substitute the value which we have got for the constant of integration, and then we just write the answer. That's it. So here also we have done dy by dx is there, y by x, y by x, y by x. So y by x we have taken as a t. Okay, after that dy by dx we need to convert in the form of dt by dx. So here we have done the conversion, and this is what we got. Our differential equation which was given over here changed to this one. Now it is integrable. We can integrate it now. Previously doing the integration was quite difficult. Now easily we can do the integration over here. Variable separable, we just need to separate the terms according to the given variable, and then we will be able to do the integration. So we have done, and then we are just doing the integration. Don't get confused, again we are substituting. That is the part of the integration. Okay, if we are having any integration, any method we have to apply, be it a method of substitution, trigonometric substitution, method of partial fraction decomposition, or method of by parts integration. So that is the part of integration. For that, for solving this integration, again we are doing the substitution. Okay, after that we are just finding according to the given condition, x is equals to 1, y is equals to negative 1. We are finding the constant of integration. Okay, instead of ln c, if you would have taken only c also, then also you would have reached to the same answer. Okay, so this is what we are getting as a c, and then substituting c and getting our answer, getting this condition. In the question it is asked find the value of phi of y square by 4. So we are thinking that okay, phi of y square by x square we are having in hand. How to find y square by 4? So that means it is indicating that x equals to 2 we need to take over here. And once we have taken x equals to 2, we got our answer 4 of 5 1 as one of the option. Is it clear?
Yes,
Is
ma'am.
it? Okay, let's move ahead. One of the question which is, I believe this type of question you have done. If dy by dx is equals to 2 to the power x plus y minus 2 to the power x over 2 to the power y, y of 0 is equals to 1, then y of 1 is equal to option A log 2 plus e base 2, option B log 1 plus e base 2, option C log 2e base 2, and option D log 1 plus e square base 2 again. Okay, let's see how to do it. dy by dx is given over here. We have to solve this differential equation. We will be doing the integration. Okay, let's see how can we do the integration over here. It is given that dy by dx. It is given that dy by dx is equals to 2 to the power x plus y, 2 to the power x plus y minus 2 to the power x, 2 to the power 2 raised to the power x by 2 to the power y. This is what we are having. The condition is there. We will be using that. Let's solve it first. So we can write this 2 to the power x plus y as a 2 to the power x into 2 to the power y, right? We can apply the property of exponents over here. Minus 2 to the power x over 2 to the power y. Now in the numerator, you can see 2 to the power x we can take as a common. So 2 to the power x we will be taking as a common. And what is left? 2 to the power y minus 1 over 2 to the power y. Okay, this is what we are having. Again, variable separable we can do. dy dx we are having all the y we will be keeping on one side, all the x terms we will be keeping on another side. So we will be having here 2 to the power y over 2 to the power y minus 1 dy is equals to 2 to the power x dx. Now we can do integration on both sides. Let's do it. So left hand side, if we will be taking the substitution as a denominator, are we going to get the numerator? So 2 raised to the power y minus 1 is equals to, let's say it is t. Okay, can you tell me derivative of a to the power x? What is the derivative of a to the power x?
XA.
Yeah, it's
A raised to x log A.
yeah, it a raised to the power x log a. Okay, so we will be using 2 raised to the power y log 2 is equals to natural log I am taking because everywhere I have seen EE. Okay, the base was E or the base was 2. Base was 2. Log I am taking. Log 2 is dy is equals to dt. Okay, so 2 to the power y dy is equals to dt by log 2 I am taking. Okay, so this is what we are getting here. 1 by log 2, this became dt over only t is equals to 2 to the power x dx plus constant of integration. So 1 by log 2, this became log of t, okay, is equals to a to the x is a to the power x by a. Okay, so what are we going to have? T is what? T is 2 to the power y minus 1. So 1 by log 2, t is log of 2 to the power y minus 1 is equals to 2 to the power x by log 2 plus c. Let's use the given condition for finding the constant of integration. So the condition is given as y of 0 is equals to 1. That means when x is 0, then y is 1. Okay. When x is 0, then y is 1. Plus 2, right? Yeah. Then y is 1. This is what we are having once we are using the condition y0 is equals to 1. Okay, let's see what are we going to get from here. So we are getting 1 by log 2. Here log of 2 minus 1. Log 1 0, right? Here we'll be having 2 to the power 0 is 1 by log 2 plus c. So left hand side we are getting 0, right? Yes or no? Log
Yes.
1, 0. So we are getting C is equals to minus 1 by log 2. Let's substitute it in our solution. So here we will be substituting it. Okay. So we are having log, let me write it here only. So we are having 1 by log 2 log 2 to the power y minus 1 is equals to 2 to the power x by log 2 plus 1 by, okay, minus 1 by log 2 minus 1 by log 2. This is what we are getting once we are substituting the value of c. Okay, log 2, log 2, log 2, we can cancel it, right? We can take it out common. Log 2 is just a value. It's just a number. We can take it out as a common and we can cancel it. So we are left with log 2 to the power y minus 1 is equals to 2 to the power x and here minus 1. Yeah, this is what we are having. Options, let me see what options are given over here. Okay. Now, if we will shift the logarithm, what are we getting? If we will shift the logarithm, here we need to use the property of logarithm, I believe, to just reach to the answer. 2 to the power x minus 1 we are having. And it is given that y of 1 we have to calculate. Okay, y of 1 we need to calculate here. Y of 1. That means when x equals to 1, then what is y? That's what we have to find here. When x equals to 1, that means here it will be 1. So 2 minus 1 we will be having. Here log 2 to the power y minus 1 still we are having. So here we are having 1 log of 2 to the power y minus 1. Okay. If we will be having, suppose here e is there. So can we say e raised to the power 1 is equals to 2 to the power y minus 1? Can we? Can we say? We are just changing the logarithm to exponent form. When we are having log a log b base a is equals to x, then can we write it as a to the power x is equals to b? Yes or no? Yes or no? Do you know this property?
Yes, ma'am.
Yes, ma'am.
Yes, we can write it like this. Okay, if we are having the base as a e, in from the very beginning we have taken the log. Okay, the base can be natural log e or the base can be 2. Sorry, the 10. The either the base is 10 or the base is e, whatever we are taking. So here we can write it as a e plus 1 is equals to 2 to the power y. Now if we will take, now it looks like we are just almost there. You can see the options. Okay, you can see the options 1 plus e, 1 plus e square, 2 plus e. So we have got 1 plus e over here. If we will be taking logarithm on both side again, so it will become log of e plus 1 over here, 2 to the power y. Again we will go 2 2 2 2 So we are taking base 2 on both sides. Okay. Now the logarithm which we have taken now in this step, we need to take base 2 because options are given in such a way. So we will be taking base 2 over here, base 2 over here. Okay. So it became log e plus 1 base 2, and here it became this exponent will come in front and we will be having log 2 base 2, and this log 2 base 2 is nothing but 1. So y into 1 we will be having on this side, and we will be having log e plus 1 base 2 on this side. So why we got log e plus 1 base 2? Option B is the correct option. Can you see? So the way we solve differential equations, same way we have solved it. Okay. At last, we have just kept our eyes on the options, and accordingly we are trying to do the arrangement. Okay. So far, till finding the value of c, that is 1 by log 2, we have done everything same. After that, it is asked that find y of 1. So we have taken x value as a 1, and then two times we have used the property of logarithm over here. And yes, we are done with the this y value, that is y is equals to log of e plus 1 base 2. Is it clear to everyone? Is it clear? Any confusion over here?
No.
Okay, let's move ahead. If one of the question is like this, let f be function which is differentiable fb, it's written as fb, not function is not written over there. Fb differentiable function defined on R such that f of 0 is equals to 1, f dash 0 is equals to 2, and f dash x is equals does not for all x belongs to R. If determinants of fx, f dash x, f dash x, f double dash x is equals to 0 for all x belongs to R, then we have to find the value of f of 1 lies in the interval is given over here. Instead of a particular value, interval is given, and the intervals are 9 to 12, B 6 to 9, C 0 to 3, and D. Let's see how to do this one. F be a differentiable function. The condition is given over here. Here one determinant is given, and we have to find the value of f of 1 by using the given condition and the determinant. Let's take the determinant first. So the determinant is we are having 1 fx f dash x, we are having fx f dash x. Here also the last one is f double dash x. This is equals to 0, that is given in the question. We know how to solve the determinant. We will do the multiplication and we will solve the determinant. So it will be f of x times f double dash x minus f dash x into f dash x. This is how we do. So we have just solved the determinant. Okay. After this, we can write this one as f of x is equals to f dash x, that's whole square. Okay. If we will take here, just a moment, no, let me check the determinant I have taken properly or not. Fx, f dash x, again f dash x, yeah, it is perfect. So if we will take f double dash x here over f, okay, this f dash x into f dash, okay, for now. So if we will take f double dash x by f dash x is equals to f dash x by f of x. This type of integration we have done. When we are taking the denominator as a substitution, we are, after doing the derivative, we are getting the numerator. Here also we are getting the same thing, if you will see. For that only I am arranging it like this. Okay, if we will take the substitution, the denominator, when we will do the differentiation of that, we will get the numerator's term. Okay, so I have arranged it like this. Then we will be doing integration on both sides. So if this side integration, this side integration. Okay, so this side you can see, you will take the denominator substitution and numerator you will get. So it will be log of f dash x. Yes or no? Let me know. Is equals to log of, just a second. Here also we'll be having logarithm and then constant of integration we have to take. So here just a second. Let me share it again. Okay, let's continue from here. So both side we are getting logarithm only. Here also we'll be having ln f of x, okay, plus c. Now the condition which is given, let's use that. So it is given that f of 0, 1, f dash 0 is equals to 2. Okay, f0, 1, f dash 0, 2. F of 0 is 1 and f dash 0 is equals to 2. Okay, when x equals to 0, then let's see what are we getting. Ln f dash 0 is equals to ln f of 0. F dash 0 is 2. Ln 2 is equals to plus c. Log 1 is 0. So c is just log 2. Okay, we got the constant of integration. So far what we have done, nothing. We have just solved the determinant and we have done the arrangement to do the integration. That's it. After that, we have used the given condition and we found the constant of integration. Now we will be just substituting it back in the equation in our solution. So this is the solution step. Here we are going to just put the value of C. So we will be having ln f dash x is equals to ln f of x ln f of x plus C we have got ln 2. If we will take this side, so we can write it as a logarithm of 2 into f of x and here we are having log here, log there, so we can write it f dash x is equals to 2f of x. Okay, this is how we can write it. Now you can see f dash we are having, f of x we are having, so again we can do the integration. Again we can do the integration, again we can do integration like this, that f dash x, because what we have to find here, see carefully the question, we have to find f of 1. So we must be having f of x in hand, then only we will be able to find f of 1. Okay, so if we can write it like this, f dash x over f of x is equals to 2. Okay, again integrating both sides, so we will be having this one as a log x and this one 2x. C we have taken already the constant, D we will be taking over here. Okay, now we can write it as, now only we have discussed that log of and we can write convert it in x to b. So if we will convert it over here, we can write f of x. Why we are doing it? Because we need f of x. Okay, so we can write it as f of x is equals to e to the power 2x plus d. This is how we can write it. Okay, so f of x is equals to this e to the power 2x plus d. If we will use the property of exponent, we can write it as a e to the power x or d. This is how we can just break the exponent. Okay, e to the power m into e to the power n is equals to e to the power m plus n. So if we are having e to the power m plus n, we can write e to the power m into e to the power n. Okay, this e to the power d is what? It's just a constant. Okay, it's just a constant, it will be a number. So instead of this constant e to the power d, I'm using one constant by my 2x. Okay, is equals to f of x. Now we have to find f of 1, no? F of 1 we have to find, that means x is 1. When x is 1, then f of k e is square. Let's see what. Okay, before that, if we will be using the given condition again, then is it possible to get the value of k here? Just a moment. Before doing this, if we will be taking the given condition, that is f of 0 is equals to 1, f of 0 is equals to 1, is it possible to get the value of k? If we will be taking x as a 0, then f of 0 will be 1. So this became 1. This is k and e to the power 0. Okay, k we got 1. Can you see? Can you see it?
Yes,
We got,
miss.
so we will be having f of x is equals to k e to the k is 1 e to the power 2x. That means only e to the power 2x we are having. Now we have to find f of 1 over here. So x we will be taking 1 over here. F of 1 will be e to the power 2 only. Now the value of e is 2.73, something like that. If we will be doing a square of that, 2.73, something like that, if we will be doing a square of that, we can see the result will be lying in between, because it's a decimal number. Okay, 2 square is 2 square is 4. Square of 3 is 9. So 2 point something square will be lying in between 4 and 9. I want to say that. Okay, let's see that option is there on 4 and 9. Okay, 6 and 9 is there. So obviously this will be the correct option. Because it is 2.7, 2.73 square. So the result will be lying in between. You see, option we will exclude. Option A, no, not at all. Option C, no, not at all. Option D, 6 we cannot say. The other end point will not be 6. So obviously option B is the correct option. Getting it? Let's summarize everything. The determinant is given over here. We have solved the determinant. See, we have solved the determinant. After that, we have done the arrangement for doing the integration, this integration. Just after solving the arrangement, the determinant. Okay, this type of integration we have done, we are doing in the last two questions also. We are substituting the denominator, we are getting the numerator. So this is what we are getting for the integration over here. We have done the integration, constant of integration, obviously it will be there. Then we have used the given condition f01, f-02 to get the constant, that is ln2. Okay, now we are substituting the constant in our solution. We have to find f of 1. So we from here we can understand one more step we have to, one more time we have to do the integration, because still we are having f dash x. Okay, so we have just applied the property of logarithm here, and this is what we are having as a solution. This solution became this just by applying the property of logarithm. Okay, again we are doing the integration. After that these are the steps which we are performing over here, that is ln f of x is equals to 2x. C constant we have taken, so to avoid the confusion we are taking d as a constant. Now logarithm, the property of logarithm to exponent form, we are writing it like that. Okay, this exponent form we have written it like that by using the natural log, and we are again using the given condition to find the constant. This e to the power d is there, e to the power d is there, so we are saying this is a constant k. Okay, and the constant k is 1 we are getting. Okay, after that we have written the solution, the final solution. There we are finding f of 1, that is e square, and according to the option we can see e square will lie in between, obviously it will lie in between 4 to 9. So if we are just eliminating the options, the given options, then we are able to find that B will be the correct option. Is it clear to everyone? Is it clear?
Yes, ma'am.
Let's move ahead. One of the question is like this. Let to yx be the solution of the differential equation to 1 plus x e to the power y minus x will lie in between negative root 2. X is lying in between negative root 2 to positive root 2. And the given condition is y of 0 is equals to 0 then the minimum value of yx x belongs to this is equal to option A 2 minus root 3 minus log 2 base e. Just a second. Let's continue. So this is what we are having as option A. Option B is 2 plus root 3 minus log 2 1 plus root 3 minus log base e root 3 minus 1, and D is 1 minus root 3 minus log root 3 minus 1 base e. Okay, this is what we are having. Let's see the question first. Y is equals to yx be the solution. Okay, y is the solution of the differential equation dy by dx is equals to 1 plus x e to the power y minus x, where x is lying in this range, y0, the condition is given over here. We have to find the minimum value of yx. Okay, when x is lying in this interval, minimum value of yx is this one. So first we must find the solution y. Okay, from the given differential equation. So let's find the solution first, then we will be thinking what to do after that. So dy by dx is equals to 1 plus x. dy by dx is equals to 1 plus x e to the power y minus x e to the power y minus x. If we will be taking this y minus x substitution, so that it will be to the power t, and we will be converting this dy by dx also. So we will be having dy by dx differentiating with respect to x minus 1 is equals to dt by dt. That means dy by dx is equals to dt by dx plus 1. Let's substitute it over here. dy by dx is equals to dt by dx plus 1 is equals to 1 plus 1 plus x e to the power y minus x. Y minus x is t. X e to the power t. Okay, this 1 gone. So we are having dy by dx is equals to x separable. Okay, dt by dx it is, sorry, dt by dx. So variable separable we will do. So dt over e to the power t is equals to x dx. If we will do integration on both the side, integrating both side, here e to the power this t will come in the numerator and will become e to the power minus t dt. Here we'll be having x dx. So let's do the integration over here, constant of integration. So we will be having minus e to the power minus t. Here we will be having x square by 2. Here we will be having only c. Now the condition we will be using, the condition is y0 is equals to 0. Okay, the condition is y0 is equals to 0. That means when x equals to 0, then y is equals to 0. But here we are having t. no worries, we have taken the substitution as t, we have taken as y minus x. So when x is 0, then y is 0. That means t is also 0. Okay. So when x is 0, then t is also 0. I am going to write it as a x is equals to 0, then t is equals to 0. Okay. We will be substituting it over here, or you can just do the back substitution of this t, and you can write it as a y minus x, and then you can substitute the given condition y0 is equals to 0. It's the same thing. Okay. So we are getting here yeah, sorry for the inconvenience. Let me share the screen. Just a second, no. So this is what we were having. Okay. Everyone can see my screen. Can you see my screen?
Yes, ma'am.
Okay. So this is what we were having. Let's substitute the given condition. So we will be having minus e to the power t is 0. Okay. Is equals to 0 by 2, that is 0 only, plus c. So we are getting c is equals to negative 1. Right. E to the power 0 is 1, and minus sign is there in front of that. So we are having negative 1. Let's substitute it over here. So we will be having minus e to the power minus t is equals to x square by 2, and c is negative 1. Okay. Now what we have to do? The solution, at first we have to find y, and then we will be thinking about the minimum value. Okay, let's convert it. So if we will just shift this negative sign on this side, it will be 1 minus x square by 2 on this side, and here we will be having e to the power minus t. Okay. And t is what? T we have taken as a y minus x, so it will become minus of y minus x over here is equals to 1 minus x square by 2. Y we have to find from here. Okay, this is our solution and here we have to find y. So e to the power x minus y it became is equals to 1 minus x square by 2. Okay. We can write it as a 2 minus x square by 2. Here e to the power x minus y. If we will take the natural log base e over here, and e already is there, x minus y. Again here, if we will take the natural log e and 2 minus x square by 2 like this, what we will be having here, only x minus y we are having. Okay, y we want to find. So for that only we are doing this one. Let me check whether this way it will work or not. So log base e 2 minus x square by 2. Okay, and this y will be x minus log base e 2 minus x square by 2. Okay, this is what we are having as a y. Yeah, this is our y. Okay, let's see the question. We need to find the minimum value of y. In the previous class only with me, we were having the discussion minima, maxima, how to check, how to find the minimum value, how to find the point of minima, how to find the maximum value. Yes, this question is talking about that minima only. We have to check the point of minima, which is lying in between minus root 2 to root 2. X is interval is given. So a point of minima which is lying in between minus root 2 to root 2, and from there we have to find the y value by substituting that minima. Okay, so in this solution we are going to use as a original equation. Now this solution we are going to use as a equation to find the point of minima. Let's do that. So what we do, we first find dy by dx, and then we find the critical point, and either the first derivative test or the second derivative test we apply to check the point of minima. Okay, from here we are going to start. So far, first let me know whether it is clear or not. We have just solved this equation, the differential equation, to get the solution. Is it clear to everyone? Is it clear?
Yes, ma'am.
Don't get confused that why again we are doing the derivative of that. We are going to do the derivative so that we will get the critical point, and so that we will be finding the point of minima now. So here it will be dy by dx is equals to 1 minus log of something is 1 by 2 minus x square by 2. Okay, that's it. Okay, this again we have to do the derivative by chain rule. So it will be 2 by 2, 2 minus x square by 2. If I am breaking it, it is just 2 by 2 minus x square by 2. That means 1 minus x square by 2. One derivative of this is 0, and derivative of this other part is minus 2x by 2. Okay, so only minus x we are getting as a derivative. I am going to write it over here directly. Okay, if you are having any confusion, please let me know. This is the chain rule I have used. Logarithm of this one is 1 by x, and then again this is not just x, so we have to do the derivative of that, which has given us minus x. So we got 1 plus 2x in the numerator. This 2 will go upside, and in the denominator we are having 2 minus x square is equals to dy by dx. Okay, we will be doing for finding the critical point, we'll be doing dy by dx is equals to 0. But let's simplify this left hand side at first. So we will be having 2 minus x square plus 2x in the numerator over 2 minus x square is equals to dy by dx. Now if we will compare the left hand side with 0, if we will compare that dy dx 0 implies that 2 minus x square plus 2x over 2 minus x square is equals to 0. Then denominator can't be 0. Okay, numerator we can compare it with 0. So we will be comparing that 2 minus x square plus 2x. This one can be 0, and This is a quadratic equation if you can see. So is it possible to split the middle term? Here we'll be having minus x square plus 2x. For finding the value of x, we need to factorize it. Plus 2 is equals to 0. Let's take negative common from that side. So we'll be having x square minus 2x minus 2 is equals to 0. Is it possible to split the middle term? I can't see. So if it is not possible, then we are having a formula, the quadratic formula, which can be applied over here. Okay, let's apply that. So x is equals to minus b. That means plus 2. Plus minus under root b square minus 4ac. So b square minus 4 into a into c by 2a. Okay, is equals to plus is equals to, here we are having 2 plus minus under root 4 plus 8 by 2 is equals to 2 plus minus this 12 by 2. Okay. Okay, let's factorize this 12. So we will be having 4 3 times 12. That means 2 root 3 will be having over here. Here 2 in denominator, we are still having 2. If we will be taking 2 common from here, we'll be having 1 plus minus root 3 by 2, 2 gone. So 1 x value we got 1 plus root 3, 1 minus root 3. We got two values of x, 1 plus root 3 and 1 minus root 3. Okay, we have to check which one is the point of minima. Okay, if we will be just locating it on real line, negative infinity, positive infinity, one is 1 plus root 3, another is 1 minus root 3. Root 3 value, if you can recall, root 3 is 1.7, 1.73 something. Okay, that means here a rough idea we are having so that we can take the test point. However, without yes, root 3 value, if you are having in mind, not the exact value, just the idea, easily we will be able to take the test point over here. So the test point, if I want to check for the first, let's check this part first. Okay, the extreme left, let's start from the negative infinity. If we will be checking over here, then we'll be checking our f dash x. Okay, our dy by dx is greater than 0 or lesser than 0. So here 1 minus root 3, that means 1 minus 1.7. Okay, minus 0 point. So here if we will be taking test point as a negative 3 maybe, if we will be taking test point as a negative 3, we need to check dy by dx. Where is dy by dx? This is dy by dx. Okay, we need to check whether it is positive or negative. So 2 minus negative root 3. 2 minus negative root 3. Root 3 no. Negative 3 I have taken no. Negative 3 square will be 9. Here negative 3 into 2 will be 6. Minus 6 over 2 minus 9. So we just need to check whether it is positive or negative. In numerator, I can see it will be negative. Denominator is also negative. So positive, right? Can you see it?
Yes, ma'am.
So dy by dx is positive in this interval. Dy dx is positive over here. What about the other interval? If we will be taking the test point, this is giving us negative value. This is giving us positive value. So 0 will be there in between. We can take the test point 0 and easily we will be getting in the numerator 0, 0, 0. We are getting 2 over here. We are getting 2 over here. So this is also greater than 0. Is it so? 0. And this is 0. And this is also 0. Yeah, 2 by 2 positive I am getting. Are we doing any mistake? No. Okay, let's check the other one. The other one, we are having 1 plus root 3. Here, if we will be taking the test point, 1 plus root 3, 1.7. So 1 plus 1.7. Here we can take the test point as a 3 or 4. Okay, if we will be taking 4, we'll be having 2 minus 4 square 16 plus 4 2 times 8 over 2 minus 16. Denominator is negative. Numerator, negative. Negative, negative, positive. All we got positive. How will be checking point of maxima or minima? Just a moment. Are we doing any mistake? We have to check. dy by dx is equals to, we have got 2 minus x square, 2 minus x square plus 2x over 2 minus x square. This is what we are having. We need to, if we are taking negative 3, obviously negative negative is becoming positive. Just a second. From here we need to get the point of minima. Okay, point of minima, and then we need to calculate y from here, and that y is given over here. Let me check where exactly we are doing the mistake. If we will be taking only the numerators part, the numerator is, the denominator is giving x plus root 2, x minus root 2, root 2 plus x, root 2 minus x, and the numerator is this one. The numerator is becoming negative in this range. The numerator is becoming positive in this range. The numerator is becoming, if we will take 4 as a test point, 4 is square 16, 4 2 times 8. So 2 minus 16 plus 8. The numerator is becoming positive. No, it's negative. Negative in this range. Yeah. Here, no, if whatever we have done so far, that is finding the solution. This is what we are supposed to do, and after that, this is how we will be checking the point of maxima and minima. We just need to see where exactly any sign error or something we have done. Please check it. Have we done any sign mistake over here or any calculation error over here? Okay, after that, I am telling you the step. Follow this step and let me know in the next class whether you were able to do or not. So we need to just find the point of minima from here. First derivative test will work over here. Okay, from minus sign to plus sign to minus sign, we need to check. Okay, for point of minima, we need to see when it is transferring from negative to positive. That means the slope is going down and then the slope is going up. That means that point will be the point of minima. Once we got that x value as a point of minima, we need to calculate the y value for that. Okay, we have to calculate the y value for that, and that y value is given in the options over this option. Do the calculation properly, because whatever we have done over here, these are the steps which we need to follow. Our y is perfect. The y which we have got over here, that is perfect. After that, just see carefully where if we have done any sign error or what. See it carefully and let me know in the next class whether you were able to find the point of minima or not from here, following this step. Okay? Is it okay?
Yes.
Yes.
Just do each and every step properly.